Okay, I'm starting again. So last week we have been discussing about the basic stuff in ROS 2, basically like the architecture and the installation. That was the last topic that we have discussed, the installation. Hope you got an idea like how to set up the ROS 2 on your machine. And we also had discussion about like setting the ROS 2 on Windows and we can set ROS 2 on Windows, also on Mac, but for the course I will be sticking on to Ubuntu because I from my experience I think Ubuntu is better to work with because we already work with ROS 1 in Ubuntu. So I think for better I will prefer like Ubuntu 22.04 with ROS 2 Humble. Okay, we can stick on to that. And we have seen the installation last week, and we also seen the script. Okay, ROS 2 Humble script. So I hope you have set up ROS 2 on your computer, and we also tried these two basic Hello World program in order to make sure the ROS 2 installation is proper. Okay, so I assume you have worked with these stuff, the installation and the checking. Okay, so today what I am planning is that I will be introducing the basic commands. Like when you start working with ROS 1, you have seen command line interface or CLI. Okay, so there are set of commands that we can use to interact with ROS, and there are also some GUI like RVs, RQT for interacting with ROS. So interacting with ROS means ROS is actually having a set of concept, right? Topics, then parameters, actions, services, all this stuff. So when multiple nodes are interacting or communicating together, they are like publishing some topics, subscribing some topics, and calling some action service, all this stuff. So all this ROS 1 concept is same for ROS 2. Okay, so I just want to mention that before discussing the CLI, ROS 2 base CLI. So when you start working with the ROS 1, in order to list down the topic, if you remember, ROS topic list is the command that we have used. So in ROS 2 there is minor difference, so I will be discussing that. So concept wise, ROS 2 communication is almost same as ROS 1, but what actually changed that I already mentioned to you, which is there is no ROS core, and we don't need to run ROS core every time when we start a node. Okay, you can simply run the node. We can focus on the node instead of running ROS core or something. So ROS core is dead. Okay, there is no ROS core at all. So last class, I remember we have seen the demo nodes. Demo nodes or like the hello world nodes in order to verify the installation is correct or not. So I'm just simply copy pasting the command. I will explain the command later. So it's like the publisher. Okay, the hello world publisher, and this is the subscriber. One second. So basically the publisher subscriber that we have done in ROS 1, we have done with ROS 2. You can see there is no ROS core and it is communicating. Let me install the Terminator app, which is much easier to work with. So you can also one second, you can also install it That is the main app that that we have to use when we work with ROS2 projects. So I'm just installing the Terminator app. One second. And yeah, it's installed. So I'm just taking the Terminator app. Okay, so here it is. So you can easily play with the command. So this is listener and this is talker. Okay, 1 second guys, 1 second. You can see the talker is publishing and listener is listening. 1 second, 1 second. Yeah, so we verified that the nodes are working, just verifying the ROS2 systems are working or not. Okay, so we are starting with this hello world example. Okay, so what I'm planning is we will be starting with these basic example and we will try to learn how the CLI stands for command line interface compared to the ROS1. Okay, so here if we want to run a node in ROS1, we basically use ROS run, right? ROS run, then package name and the node name. So if you remember the command ROS node or ROS run in ROS1, this is the syntax. Okay, so it's almost same in ROS2. The only difference is that instead of ROS run, the ROS2 commands are like the first part of the ROS2 command is ROS2, simply ROS2. Okay, and after that we have to put a space. Okay, this is applicable for all the commands. Okay, so first is a keyword or an identifier, ROS2, that is the first one, and then what to do. Okay, so running, right? So ROS run. So instead of ROS run, we can simply put run. So if it is a topic, like if you want to list down a ROS topic, or if you want to use a command instead of ROS topic, we can simply type topic. Okay, if it is a parameter, param. If it is a service, service. If it is an action, ROS2 action. So this is a major difference in the CLI. Okay, so there is a slight difference when you type. I mean, I will say for me, like when I started working with ROS2, yeah, there will be an issue because these ROS2 is coming first, right? These ROS2 is coming first, so there is some confusion, but it will go after working with I mean few projects. Okay, it will take some time. Okay, if you are already an expert in ROS1, then migrating to ROS2 will take some time to adjust. Okay, so I'm just running the node ROS2 run, and then the syntax is the same like the package name. Okay, the package name. So there is a package called demo node cpp. Okay, so when you install ROS2 Humble on your computer, there is a demo node cpp package. You can find that package from the OPT. Like if you just go to /opt ROS Humble, you can simply check the demo nodes cpp. So this is the package that we are talking about. Okay, so it's already installed. So what we are trying to do is mentioning the package name and then the node name. Okay, so just enter. No need to worry about the row score and all. So what it does is that it is starting a node called talker. Okay, node means it's not node. Talker is actually an executable. Okay, so when we execute the Talker executable, it will run a node. Okay, it will run a node, roast node, and then it is publishing a text or string at a frequency of 1 second. Okay, like it is having a delay of 1 second. Okay, that is what we are seeing here. Okay, and then we are starting the listener, so there is not much difference for the listener. We are running the same, and you can see the latest text is displaying here. That means there are something going on, right? Subscribing going on. So how to visualize the computation graph? Okay, so the concept of computation graph is same in rows 1 and rows 2. What is computational graph? Computational graph means the graph forms when multiple nodes are communicating together. Okay, so which is the best tool for visualizing the computation graph? It's RQT, right? RQT, using RQT we can do. So in rows 2 also there is RQT. So simply type RQT. There is no difference when we compare with rows 1. RQT will work, simply running RQT. And then if you want to visualize the computational graph, you can go for introspection and node graph. So it's the same RQT that you are seen with rows 1. Okay, and what you can see is the same computation graph that we have seen in rows 1. Okay, the same thing. So the talker, listener, and the chatter is the topic name. Okay, so we get to know what is happening in the background, and then so this is a visualization of the computation graph, right? So let's work with some commands. Okay, CLI, command line interface. So we can start with the rows topic. Okay, so rows 2, then topic. Okay, so first thing is we need to list down the topic. What are the current topics? So we get to know there are 3 topics, and rows out parameter even you can ignore for now. Then the chatter. Okay, so chatter is there. So what about echoing it? So rows topic, then echo chatter. Okay, so we are getting the same data which is publishing. Okay, so this session we are just familiarizing with the CLI, just familiarization, just an introduction. The next part will be using TurtleSim. So using TurtleSim you will get much more clarity working with all the rows concept, which is topics, services, action, parameter, everything. Okay, so so this is rows topic echo, and then rows 2 topic. Yeah, so if you want to get help about one command, okay, so if you simply type rows 2, it will be giving, or it will be showing the sub commands that we can work with rows 2. So don't worry about finding what command that we have to work with. It's very simple. Just type rows 2, and then you are going to get all the sub commands, or the main commands that we can use along with rows 2. Okay, so if you want to check about rows 2 topic, so simply type rows 2 topic. So you are going to get the help of the rows 2 topic. Okay, and then rows 2 topic info. If you type it, then you are going to get the help of that topic. Okay, and there is a small description, so I think you can easily understand what is going on. Like if you type list, it will be listing the current topics. If you use the BW, it is going to display the bandwidth of a specific topic. It's the same as the things that we have seen with the ROS one. Okay, so here you can see the BW topic, and if you want to display the delay, I think delay is a new one. Okay, delay is a new one. So it is like display the delay of a topic from a timestamp in the header. So I don't know which will work here. Okay, and also there is a find. So output a list of available topics of a given type. Then we can publish a message to a topic that we can try, and then print a topic type also. For example, topic type chatter. You can find standard message string. Okay, so there is a minor difference that you are seeing here, right? So in ROS 1, if you check, it will be standard message / string. Okay, so in ROS 2, the same message, there is no difference in the message, but they added MSG. Okay, MSG to indicate that it is a ROS message. Okay, ROS message. Okay, so if it is a service, it will be, I mean, if you are finding a type of service, I think this will be SRV, and action, will be action. I need to double check it, but they actually added this MSG for identifying it's a ROS message. Okay, so I think simply the ROS2 command will give you the power to understand all the things that we can do with the CLI, ROS2 CLI. Okay, and let me check the publishing of the topic. 1 second. There is a syntax for that. So it's the same, but there is a small difference. I need to, so here I'm just following the tutorial, so you can also check the tutorials. That will be better, I think, rather than using custom tutorials. 1 second, guys. So ROS2 topic pub. So what is next? The topic name, then the message type, and the data. Okay, so before giving the data, we have to that is what I need to check. Wait a second. It should be in a YAML format. So when we yeah, that is what I think data. Wait a second, I'm just taking an example here. Let me try this. One second. The publishing is actually confusing for me because the method that we are using in ROS 1 it's like we are just completing the message header, but here we have to do it in a different way that you can note. There is a minor difference. Yeah, I think this is okay. So like you can see, we are publishing a message, a text string data from the rows to topic command. So you can see in the subscriber, here is a subscriber, so it is getting hello world and test. So test is the text is the string that we are publishing from the command line, and hello world is talker is publishing. So maybe I can show it to you like the RQT computation graph, so you will get an idea. One second. Unfortunately, the other thing is not listing down. One second. So actually sometime this will happen. At that time I need to just reset the rows to daemon, but here you can see it's only showing talker and listener, but there is another node. Okay, so if you simply check rows to node list, okay, it is not showing as a node. Okay, fine. Wait a second. Let me just close all and check it again. Just starting talker and checking talk. Okay, and then I'm just starting a publisher from the command line. Okay, so basically it's not detecting as a node, that I need to check it out. Okay, that I will get back, guys. So what I am trying to do is that, like in rows 1, if you start a node and if you publish something from the command line, what we are doing is rows to topic pub is actually a program. Okay, so when we start running it, it will become a node. Okay, but in case of rows 2, it's not detecting as a separate node. Okay, it's not showing as a separate node, so I need to recheck that. I am only testing that now only. I mean, I didn't check it before, but this is detecting as a different node. So if you running the listener, it is showing. Okay, so I will check that. So what I was trying to say is that if you publish something from the command line, so this is the format. Okay, this is the format. Up to this, I think you may be aware of rows topic pub, topic name, message type. So in the message type, you have to use the MSG. Rest of the things are the same, and this is where the difference comes. So if you put a data on the command, the data format or this format should be in a YAML format. Okay, meaning it's like if you check the string message, it will have a member called data. Okay, so in rows 1, what we are basically doing is that we just want to do like this. I mean, not even we don't need to put the data, we can simply do like this, it will work. So the data will be setting as test string, but in rows 2 we have to mention that data is test. Okay, and this representation should be in string. Okay, and you can see this is the way we have to I mean, this representation will only work if you put the things like the representation that we are used in rows 1. It will say like the past value need to be a dictionary in YAML. Okay, so I will show you a big example like for the representation. You can see here like we said, you can see, just a second, yeah, in a bracket you have to mention each field inside that service or a message. So in this service we have X, Y, theta and name. Okay, so inside the brackets we have to mention X, Y, theta and name value. Okay, you have to mention all these things and closed we have to mention everything in the quotes. Okay, opening and closing. Okay, so this is the main difference if you are publishing a topic or service from the command line. Okay, so these are very basic stuff. So but you should be careful. Even I had some issues while publishing because the rows 1 representation and rows 2 representation will confuse me sometime. Okay, so I hope you got a clarity like how what are the main difference in the command line. Basically if you already know rows 1, there are a lot of similarities, and the main command that we can use to learn this CLI is rows 2 itself. Okay, so you will get to know all the main stuff that we require to work with the rows 2 CLI. Okay, so what I am trying to show you next is the turtle sim, which is the first tool that we can use to learn rows 2 again. So the turtle sim in rows 2, it's the same thing, but they have added some more stuff into it. So I can show you that. Yes, I'm just sharing the link that I am referring. If you want, you can also check. Yeah, so in this link, this is the command to start the turtle sim. So let's me start the turtle sim. I mean, it's already installed, mostly it will be installed, so I'm just starting the turtle sim here. So if you check the link, this is the link, you can see here, if your installation, if the rows installation doesn't have turtle sim, you can install that using this command, rows humble turtle sim. Okay, but if you already installed desktop full, it will be there. Okay, and this is a command to check the executable inside the turtle sim package. So there is a package called turtle sim in rows. So if you want to check what are the executables inside it, you can easily find using this command, rows 2 package, then executables, then the package name. Okay, so if you want to find what are the things inside the package command, you can create a package using rows 2 package, executable, list the available packages, all these things you can use the rows 2 package. Okay, so here we use rows 2 package executable turtle sim. So it will be listing down the nodes inside it. So the first node that we are using is turtle sim node. Okay, so this is the node that we are using, turtle sim node, and you can see the same turtle sim that we have seen in rows 1. Okay, so what are the difference then? So in order to find that, the best thing is rows to topic list. Okay, so if you do the rows topic list, you can find the list of topics that is providing by the turtle sim. So if you check the topics, if you remember the rows 1, it's almost the same. Okay, we have the command velocity, we have the pose topic which is giving the turtle sim pose, and there is the output from the color sensor, all these things. And if you check rows to service, okay, which is for interacting with the rows to service, you can find the list of services available. Okay, and now there is a new one which is rows to action list. So if you remember, the rows 1 turtle sim doesn't have actions on it. Okay, if you want to learn action concept, there was no actions on this node. Okay, so the turtle sim node is like, it is having all the concept implemented, and the main purpose of this implementation is mainly for learning. So it is having parameters, services, topics, and action. So if you check rows to param list, you can find the list of parameters available. Okay, so background BGR, these are the main parameters that is available. Okay, so from the turtle sim, it's very easy to migrate to rows 2. So we have we got the turtle sim, and then the same commands that we can use, almost the same commands. If you just check the teleop command, it's again simple, like rows to run turtle sim turtle teleop key. Okay, so you can use the arrow keys in order to move the turtle on the turtle sim. You can find it. So same stuff. And then if you want to check the computational graph, you can use RQT, and then better will be, yeah, this is okay. Yeah, so this is a computational graph. You can find there is turtle sim node here, then teleop turtle here, and when the teleop turtle, which is the keyboard teleop node, give the command velocity to turtle sim, is actually giving the status, then the feedback. Okay, so basically what changed was the teleop turtle in rows 1, they have been using the topics. Okay, but here the implementation is actually using rows to actions. Okay, so you can find what are the main components of action. There is a feedback, there is a status, and there is a goal, right? So here the goal is going to be the command velocity is actually going by a topic, but the rest of the things, the feedback, status, all these things going like a action. So if you just check the ROS2 action, one second, ROS2 action list, you can find this action. Second, yeah, you can find turtle1 rotate absolute, okay, which is the action name, which can be also find here, okay, turtle1 rotate absolute, okay, this is the action. So I just want to show you, like, the ROS2 turtle sim is having all the ROS2 concept implemented. So what is the advantage of using turtle sim? You can work with, or you can play with all the concept, and thereby you can increase your knowledge on this concept. Like, you can write a program in ROS2 to communicate with turtle sim, so that you will get an idea how to write a node to communicate and to communicate via topics or service or actions. Okay, so that is the main agenda of, like, including turtle sim in ROS2 or ROS1, and you can easily migrate to turtle sim in ROS2 without without confusion, because it's almost the same, and you can find the nodes, topics, service, action, all these things are mentioned in the tutorial itself. Okay, so following the tutorial will be easier for you. So I'm just going through it. These all are the basic stuff, so I think we can use the main documentation, which is this. And then there are options. They are giving instruction to interact with the service that we already played with in ROS1, but I can show you it in ROS2. So let me start the turtle sim, and then let me start the Teleo, and then you can move it. You can move the turtle, and then if you want to clear it, okay, if you want to clear the turtle or reset the turtle, we have services, okay, ROS2 services. So you can see the services like clear, kill, reset, spawn, then set pen, all these services are there. Okay, so you can interact, or you can call the services using CLI, like this, service call, and the service name, okay, and the type. Okay, so basically all these services are empty, okay, empty services, standard service / empty. So you have to mention the type, and then in an empty service there is nothing, so you can simply put like this, an empty braces, and then that's it. It's actually reset. So I can show you the syntax again. So in order to call a service from a command line, ROS2 service that you know, and service call, ROS service call you already know. So what remaining is that the name of the service, type of the service. Okay, so if you mention ROS message, ROS service, ROS action, you have to mention the package name. Then if it is a ROS message, you have to mention as MSG. If it is a service, you have to mention as SRV. If it is an action, /action. Okay, So /srv and empty. So most of the messages in rows 1 and rows 2 are the same. Okay, only this representation is different. Okay, yes. And then if you want, this is an empty service, right? So you can give an empty parenthesis braces. Okay, so if you can do the same like this, so you can understand what happened. After this, I'm just calling the service, and you can see it is resetting. So when you call the reset, the turtle also change the logo. Okay, the image of the turtle is also changing. Okay, and another way of interacting with the services are the RQT. So in RQT plugin, if you just go to service caller, there is an option to call the service from a GUI. So it's very easy to interact with. Just select the service, and 1 second. And then you can mention the data here. So if I am just press call, it's showing like this expression is not, so we have to give the expression as this. Let me try this. Let me try this as well. Okay, like this. So here I think the expression is different. While working with the RQT, I think it's there. 1 second. 1 second, I think it's mentioned here. So from the official tutorial, they mentioned the command line interface. That is what we have done, and they also mentioning the GUI. I think they have shown somewhere. Let me just check. Yeah. So this is how we can interact with the service. We have to fill the data here. So if it is an empty service, they have shown you the what data we have to give. For example, the clear or reset are empty service. So the expression that we have to give is, they are saying it should be 0. Okay, let me try. Just a second. Reset. Oh, okay. Yeah. So that was an issue from my side. I was actually taking the kill service. Okay, so for kill service, we have to mention the name of the turtle to be killed. But if it is clear, then we don't need to do anything, just call. Okay, so if it is reset, just call. You can see here. I was also having some confusion because for empty services there is no field at all. Okay, so if you simply call it, you can find the turtle is resetting. and if I'm just moving the turtle, and then if I'm pressing reset, it is resetting. Okay. So this is how we can interact with services in ROS 2, one way. Okay. Also, if you want to interact with the topics, there is another plugin, I think you already know, Topic Monitor. So using that, you can able to monitor the topics. Monitor means you can echo it, or like you can visualize it. For example, if you just subscribe to the command velocity, one second, if you just move the robot, you can able to see the values changing here. See, these are the command velocity values. One second. You can see here these command velocity values are changing. Okay, so for monitoring topics, we can use Topic Monitor. Then for interacting with services, we have the Service Caller. Then there is Action as well. So this is not for like calling actions, it is like just for visualizing, I guess. Yeah, just for showing, or just for visualizing the action message. Okay, so I hope you got an idea about the turtle sim in ROS 2. It's very simple. It's the same thing that we have used in ROS 1. We can able to interact with the topics, service. They have given us some examples to interact with the services. For example, this is like spawning a turtle. This we can use the GUI or like command line. For example, I started the turtle sim here, and then I'm just calling a service called spawn. Okay, so I'm just calling like ROS 2 service called spawn, and then this is the type message or service type that we are using, and this is the data format. Okay, I already mentioned that the data format, or the data that we are feeding to the command line should be like a dictionary format, YAML format. So inside the braces, we have to give the position of the turtle to spawn. Okay, and also the name of the turtle. So if you do that, it's actually created a turtle with a name of Lentin. Okay, and if you do the ROS 2 topic list, it's basically creating the topics with the Lentin namespace. Okay, so the same thing that we have done with ROS 1, only the command line interface is different, and also the data format. Okay, I hope you remember the stuff. Okay, and we have the parameters as well. So we can just play with the parameters next, and then we can conclude today's session. So in order to interact with the parameters, again the ROS 2 param topic that we are using, if you do the ROS 2 param list, then you can see the list of parameters available. So ROS 2 param get, then the parameter name, One second. So in order to get a parameter, this is the command that we have to use. Rows2 parameter get, param get, then the node name, which is showing here, okay, and then the parameter. So it's an integer, and you can see the values 255. Okay, it's a parameter value for the blue. If you just change to green, then its value is 86. If it is red, then it's 69. So it's a these are the parameters for setting the background of the turtle sim. Okay, and in order to set the value, again it's easy. Instead of get, we can put set, and then node name, then the parameter name and the value. Okay, if I'm setting the red background red as 255, you can instantly see it's actually changed. Okay, so there is a difference in rows 1 and rows 2 here. I don't know, like, you observe that or not. So in rows 1, just changing the parameters will not change the color. After that, we have to reset it. Okay, then only that change will be happening. But in rows 2 param, you can set the param and it will be updating instantaneously. Okay, so I'm not sure you remember about the dynamic reconfigure type parameters in rows 1. What happening is that rows 2, it's like a static kind of variable. Okay, I mean rows 2 variable, rows 2 parameter or rows 1 parameter, we will think like it is like a static parameters. Static means like we can set that value and then we can read from it. Okay, that was correct for rows 1. Okay, but in case of rows 2, there is a change, or it's a good change actually. Whenever there is a parameter change, you can call a callback. Okay, and then you can update it. Okay, so in rows 1 also there was a feature called dynamic reconfigure, which is doing the same thing, but in rows 2, this dynamic reconfigure kind of parameters is the default. Okay, so if you set a parameter, the advantage in rows 2 is that you can instantaneously update. Okay, because a callback will be calling and then we can modify it. Okay, so the parameter with callback is one new thing with the rows 2. Okay, yeah, so if I changed to 0, you can see it's changed the value. Okay, so this is with the parameter. We have tried the set and get. It's actually mentioned in the tutorial, and also we can maybe save the parameters, like, you know, like dumping the parameters in a YAML file, that also possible. So these are the main things. I think we have checked the main, I mean, we have discussed the main things. The rows action is there, that I think we can discuss that tomorrow, so it needs some more explanation. And then we will be discussing other basic concepts. We also see how to create a package, then how to build it, how to write a node in rows 2, and how to build it and how to run it. Okay, Yes. So that's it, guys, for today. We can continue tomorrow with these basic concepts. Okay. So one thing, one suggestion is that just follow these tutorials, and you can have you can have a try on your computer, and let me know if you have any confusion. Okay, while you try, if you have any confusion, let me know, because uh, you can just compare with rose 1. It's mostly same as rose 1. So just have a try and then let me know. Okay. And yeah, so tomorrow we will be discussing this beginner session. We will be discussing action, then yeah, then the launch file, the basic launch files, then bagging, how to do the bag files, yeah, all this stuff. Okay. So
I have a small question
yeah,
here,
yeah.
not on this topic,
Okay.
on the publisher subscriber. There is also parallelly now going on the micro rows, right?
Yeah,
Right.
yeah.
So micro rows, I assume we don't require any kernel of the rows, only the architecture wise, uh, only sub only it will take it, right?
It will take all the things, because it is also running a lightweight footprint of ROS 2. So I think we have seen the architecture last class. Maybe I can take it. It is running a very lightweight footprint of DDS as well. So basically, micro ROS, it's like a micro version of ROS 2, and it is having all the API, all the concept of ROS 2. So you can see here, the main difference is that
Okay.
here there is a microcontroller, and there is a operating system, real-time operating system, and on the top there is a middleware. So it's again a DDS stuff, and there is
But is it required this real-time RTOS,
yeah, because
or only micro rows is enough?
uh, no. I mean, the micro rows comprises of, I mean, uh, in order to run the micro rows, we need a real-time operating system.
Okay,
Okay,
okay.
so basically, if you check the tutorial, we can see some Docker based container for checking it. But in reality, like when you try to flash, you can see here, we need I mean, a real-time operating system. They have the uh, setup instruction here, so it's very similar to the ROS 2 itself, that in the computer. Okay, it's almost the same, but it's a very micro footprint. I mean, we are running a
Okay.
very micro footprint ROS 2 on a microcontroller. So
Yeah.
it is having the RCL. RCL means the um, the client library in C. So that is actually the foundation for RCL CPP, RCL Pi, and other language wrappers. Okay, so you can see here, we will get publishers and subscriber, services, parameter servers, all this stuff we will get. Okay, I'm not sure about the action, but these stuff we will get from the micro rows. Okay,
Okay.
okay.
Yeah.
Yes,
Thanks.
yes. So any more question, guys?
Yeah,
Yeah, yes.
in continuation with this question,
Yeah.
so is it micro ROS independently can run, or do we need always with a ROS 2 companion?
Yeah, it's actually depends on our application. For example, here you can see, uh, on the left side, everything is running on the microcontroller. Okay, so if you want to create an independent microcontroller application that doesn't need any kind of connectivity to the external world, then you can do. Okay, but in reality, when you work with the robots, there should be some connectivity, right? Some kind of connection to a PC or a mobile. So that is what on the left side. So it's like the micro ROS based microcontroller is communicating to a ROS2 agent which is running on maybe a laptop or some other computing device, and then it is connected through some protocol like Ethernet, Bluetooth or serial. Okay, so it can work independently, but mostly like for the robots it may need some connectivity, like these microcontrollers will be mostly putting in a robot, right? So in that case we need some connection, and then we will get the topics from the microcontroller in the laptop. Okay.
Yeah.
Okay.
But it will act as a like a only slave kind of thing, right? It doesn't have much. I mean to say, if
I'm not sure you work with the ROS serial Arduino in ROS 1. It's actually kind of
No.
the ROS serial Arduino in ROS 1. It's like I will say the micro ROS is a successor of that ROS serial Arduino. In ROS serial Arduino, we are making the Arduino as a ROS node. Okay, ROS node. It can do whatever a ROS node can do. Okay, and it has to communicate with the PC always. But in case of micro ROS, we are running an independent or like a very micro footprint of ROS in the microcontroller. It is having an an OS layer and also the middleware. So connecting to the agent or like external device is not mandatory. I mean, it depends on our use case. If there is a connectivity required, we can. So it's like more upgraded form of ROS serial. It's a very micro computer running ROS 2. Okay, so depending on the computational capability, we can do more advanced stuff on the microcontroller. Okay, so it's not only like a slave, it's like a microcomputer which can do lot of stuff compared to the real computer. Like maybe if the microcontroller can able to process some images, it can able to publish it. If the microcontroller can able to process an image, maybe it can subscribe the image from the laptop and do the processing. Okay, so we can treat the micro ROS based microcontroller as a microcomputer. So it can do almost all the things that is doing by the main computer. Okay.
Okay, thank you. Got it.
Okay, so now I think we can conclude today's session, and we can continue with the beginners session tomorrow as well using the official tutorial. So you can simply go through the tutorial, you can simply work on these commands, then only you will get an idea. Okay guys, thanks for attending. See you tomorrow. Bye everyone.